Hi, and welcome back to the Implementing and Administering Cisco Solutions CCNA 200-301 video series course by AC Council. My name is Glenn Singh. In this video, we are going to take a look at configuring and verifying Layer 2 discovery protocols. So let's dive on in. So you may be wondering, what exactly is a Layer 2 discovery protocol? Within your Cisco switches and routers, they continuously exchange information with their neighbor connected devices. This helps a device to determine what type of device is connected on the other end. Additionally, Layer 2 discovery protocols help us as network engineers to map a network without seeing a topology. The Cisco Discovery Protocol, also known as CDP, is a proprietary protocol which operates between Layer 2 and Layer 3 of the OSI model and also the TCP/IP protocol suite. CDP is actually used to assist Cisco switches to learn about their directly connected neighbors and other switches and routers on the network. CDP is enabled by default on all Cisco routers and switches. Once CDP is enabled, they will send advertisements or messages to the multicast address or the multicast Layer 2 MAC address as outlined here. When a switch or router is sending CDP messages, these are what is contained. It contains the iOS version, the device model and type, connected interfaces for both the local and remote devices, even host names. Additionally, if a device has a Layer 3 interface, whether it's a physical interface or a logical interface, and there's an IP address on it, the IP address is also shared within the CDP messages. On your Cisco routers and switches, CDP is enabled by default. But let's imagine that CDP is not enabled. To turn on CDP globally, you can go into Global Configuration mode and use the CDP run command. This will turn on CDP on the entire switch. Therefore, CDP will be sending and be accepting messages on all of its interfaces. To enable CDP on a particular interface, we can access interface mode. So as you can see here, interface fast Ethernet 0/24, and we can use a CDP enable command. If we use this command, CDP will be enabled on this specific interface. So this means, why would you want to enable CDP on an interface only? Well, imagine a malicious user who is between, let's say, a couple of your switches, such as this. By default, these switches will be sending CDP messages. If there's an attacker who's sitting down in the middle, such as a man-in-the-middle attack, this person may be able to capture your CDP messages. Additionally, it is recommended that CDP messages only be exchanged between switches and between routers. Therefore, if let's say we have on switch 2, we have end devices such as PC 1, 2, and 3, it is not recommended to allow CDP messages to be sent to end devices. CDP messages should only be kept between switches and between routers, simply because end devices such as your PCs, your printers, servers, these devices are not concerned about CDP messages at all. So therefore, it is recommended to keep the CDP messages between your switches and between switch to routers. To verify that CDP is working, you can use a show CDP command. And as you can see here, the hold down time is 180 seconds. Most commonly, you will be using the show CDP neighbors command. This command will show you a summary of what is connected to your local device. So therefore, if we look at the information here, we can simply determine this. There's switch 1, and we want to determine what is connected to switch 1. We use the show CDP neighbors command. We can see that there's a neighbor device named r1.tt. And we are using our local gigabit Ethernet 0/1 to connect to r1.tt. Furthermore, we could see the capability or the capabilities of r1.tt. You can see R. If we match R with the codes, you can see it is a router. Furthermore, we can determine the platform of the router. which is a C2900. And lastly, we can see the port ID that is used on R1.TTN, which is Gigabit Ethernet 0/0. As you can see how simply it is that we can map our network. So let's say you don't know what is connected to the other end. You can simply use the show CDP neighbors command to verify the type of devices, the interfaces that are being used. Additionally, if you want to get an IP address of your neighbor devices, you can use a show CDP neighbors detail command. For example, R1.TT is a router, and look, we actually got the actual IP address of R1.TT. We also got the platform, the capabilities, the interfaces being used, the port ID information, and so on. This information is very useful if you have to remote access a device but you can't remember what is connected to which particular interface, plus if you can't remember an IP address for a neighbor device on the network. Additionally, you can use a show CDP entry space asterisk command, and this will give you a lot of information similarly to the show CDP neighbors detail command. As you can see here, we got the neighbor device detail, which is R1.TT. We got the IP address. We got a platform, which is a Cisco 2900 series device. We got a capability, which is a router. We got interfaces and port ID information. So now let's take a look at doing some basic commands on a CDP lab. However, you can use the same VLAN lab that you have previously to perform this exercise. So we have the VLAN lab. Let's click on switch 1. And let's do the show CDP neighbors command to verify what is connected on switch 1. Now hit enter. And if we look closely, we can see what is connected. We can see switch 2. We can see our local interface we are using to connect to switch 2 is fast Ethernet 0/23, which is accurate. We can see the capability switch, S for switch, so we know definitely it's a switch here. We can see the platform, which is a 2960. We could also see SW2 interface that is using to connect back to us, which is fast Ethernet 0/23 as well. Simply like that, we can get details. We could even map our network. Notice here that CDP is actually enabled by default. This means that CDP messages are being sent out of these individual interfaces as well. What if we want to keep the CDP messages along this link only? How can we do this? Well, we can simply disable the CDP messages from going outside of our access port. And we could do like this. We are going to use the interface range command because it's fast Ethernet 0/1, 0/2, and 0/3. We can use a no command and press question mark. So because we type no space question mark, we can use the CDP command. So let's do CDP and question mark once more. And the only other command that is available to us is enable. So which means if we type no CDP enable, we'll be disabling the CDP messages from going out of these interfaces, therefore implementing a security control. And just like that, we have disable CDP messages from going out of these three interfaces. Hence, CDP messages will only be exchanged from switch 1 to switch 2 only. Another Layer 2 discovery protocol is known as LLDP, or Link Layer Discovery Protocol. With LLDP, this is another discovery protocol which operates over Layer 2 and it is supported by non-Cisco devices. This means it is open source because it is defined by IEEE 822.1ab, which makes it interoperable with mixed vendor devices. So let's imagine that your network has Cisco and non-Cisco devices, but you still want to get the effect that CDP does for us. Well, we can use LLDP. To configure LLDP, we firstly need to turn it on globally, because it is not enabled by default on Cisco devices. To do this, we log into each device that we want to enable it, go into global config, and use the LLDP run command. Once we do the LLDP run command, we log into each interface that we actually want to exchange messages with, and we use the LLDP receive and the LLDP transit message. This will allow the device to exchange LLDP messages with its neighbors. So let's try this in our lab between just two switches. And we are going to use the same VLAN lab that we was using in the previous videos. So let us click on switch 1 and turn on LLDP. Now that we executed LLDP run, LLDP should be enabled globally on the switch. Let us exchange LLDP messages or only use fast CCNA 0/23 to exchange LLDP messages. So therefore, overall, we want to exchange messages between switch 2 and switch 1 on the network. To do this, let us go into fast CCNA 0/23, use LLDP transit and LLDP receive. And that's it for the configurations for SW1. But we need to configure SW2 to also send and receive LLDP messages on the same trunk interface that is connecting switch 1 to switch 2. Since we are already on switch 2, let us do some show commands for LLDP. Similarly to CDP, we can use a show LLDP neighbors command. And this will show us what is connected to switch 2, because right now we're on switch 2, so you can see switch 1 is connected. We are using our local fast 0/23. The capability is B. What is B? B is a bridge, because they do not have the word switch anywhere here in their compatibility codes. We can see the port that SW1 is using to connect back to switch 2, which is fast CCNA 0/23. Furthermore, we can use the show LLDP neighbor details command. Having executed the show LLDP neighbors command, we actually got a chassis ID of the neighbor, we got a port, we got a port description, the system name, we got other details about the device as well. We see that it's a C2960, we got a version of the operating system of the neighbor, and many additional details. However, if SW1 had an IP address on it, we would have gotten the IP address of SW1 simply by using the show LLDP neighbors command. Well, the show LLDP neighbors detail command. An additional command to verify whether LLDP is enabled on your switch. You can use a show LLDP. You can see the status as active. The default advertisements timer is 30 seconds, while the default hold down timer is 120 seconds. Here is another example where we use a show LLDP neighbors detail command, and looking at the information, we can simply determine this. Currently we're on SW2. We have one neighbor, which is SW1. Our local interface is Fast Ethernet 0/24. The capability is B. B is bridge, but we know it's actually a switch. The remote port ID is Fast Ethernet 0/24 as well. Here we have the output of the show LLDP neighbors detail command. As mentioned, you would get a chassis ID, the port ID, port description, system name, additional details about the neighbor device. In this video, you learn about the benefits of using a Layer 2 discovery protocol. You learn how to implement and even configure CDP, Cisco Discovery Protocol messages. You learn how to configure LLDP as well too within a Cisco network. In the next video, we'll look at configuring and verifying something called Ether channels. I hope this video has been informative for you, and I hope to see you in the next one.